So we're on page 6. Okay, here we go. We're looking at this problem here. And here's what we got to take, people. Here's the important part. This whole problem is talking about a limit. And they're using this table for you to evaluate it. But they're trying to trick you. Meaning, am I allowed to dissect each part of this? Yes. Let me tell you what I'm talking about. I need to evaluate this first. What is the limit as x approaches 3 of h of x using this info? What do you think? Isn't that just going to be 2? Because there's the f, g, h. You see what I'm saying? You agree that's 2. So this part right here is a 2. But then I'm also going to bring this 2 down. But then what I need you guys to realize is when they ask for that f of x, they're still asking what is the limit as x approaches 3 of f of x. Limit as x approaches 3 of f of x, you agree, is another 2? So many 2's. So that one's 2. Plus 3, I'm bringing that guy down. And again, just know that they're saying the limit as x approaches 3 of g of x. What do we think? 8 times 8, girl. All right, in the parentheses first, 2 times 2. 4 plus 24 is 28 times 2. You got it. Boop. Okay, let's take a peek at this guy now. Let's take a peek. Let's take a peek. They're asking as x approaches 2 from the positive side. If I look at a number line, 1, 2, 3, what number, how would I be approaching 2 from the positive side? From the right or from the left? From the right, you're saying? From the right, it would go like that. I completely agree. If I'm looking at this function, which is a piecewise, as x approaches, if x is less than 2, what do you think? Is that coming from the left or from the right? If x is less than 2, is 1 less than 2 healed? You okay?
Yeah.
Okay.
We're just figuring out.
Okay, here we go. So, as I approach 2 from the positive side, you guys, if x is less than 2, give me a number that's less than 2.
1.
So I'd be coming like that, right? If x is less than 2, I'd be coming from the left-hand side. We said we wanted to be from the right-hand side. So I'm not even going to pay attention to that top function. Cuckoo? What is the middle referring to? F of x equals 9 when x is 2. That is a straight up point. How would I write that point? Just straight up 2, 9. Okay? What's this one saying? If x is greater than 2, do you agree 3 is greater than 2? 4 is greater than 2? 2.1 is greater than 2? So does that make sense that we're going to use this bottom function if we want to analyze this limit as x approaches 2 from the positive side? And what we're learning today is we get to literally just do direct substitution. You just plug in a 2 to that function then. What is 4 times 2 plus 3?
11.
Done. Totally, yes, if it wasn't a multiple choice. All they're testing here, you guys, is if you can put this superscript into an inequality. That's all they're testing there. You guys, I just put this in here because this is kind of interesting, I'd say. Look at this first picture. Would you say the limit does not exist as x approaches 0?
Yes.
Why? What happened to my fingers? They did not come together, right? What about over here, G? Limit as x approaches 0.
It's not happening.
Does not exist, I agree. But what happens if I add my functions together? If we were to say this is like -1 over here, and if my y was 1 over here and -1 over there, what's -1 plus 1?
0.
You agree they kind of put the left-hand side, they add the functions. Over here we got -1 plus 1, you agree is? 0. So what's the limit as x approaches 0 of f plus g?
0.
Yeah. So this is just a fun little fact to say, even if the two functions, the limits don't exist individually, if we compose them together, my limit could equal a value. Cuckoo? That's just a little fun little fact. Let's go right here. Look at this crazy thing. I'm going to show it to you on Desmos. X cubed, you don't have to do this graph. Let me just put it up here for you. Boom. Here's the graph. Where did it go? There it is. You guys, as x approaches 1 is when they're curious what my limit is. As x approaches 1, does it appear that there will be a limit?
7. Yeah.
You think it's going to be 7? You think it's going to be 7? I'm going to just put a little 7 over here as a little reminder. Okay. You guys, just like we did lie on that last one, we just plugged in Well, they were asking when x approaches 2 from the positive. We just plugged it in. That's our go-to. We always just try to plug it in. Plug it in, just like those Glade plugins. That's right. You guys, I heard it. Healed, what'd you just say? He says just 7, because when I plug in a 1 for every x, 1 cubed is 1 times 12 minus 5, which is just 7. Direct substitution is the bomb. AP will give you a direct substitution question. It's really nice. Let's go try this one. First, I want to show you the graph on the Desmos. Let's see if it is a thing. What do we think about this guy? As x approaches 2, does it appear to have a limit? What do you think that limit's going to be? 3. You're thinking it's going to be 3. Do you think we can just plug in?
Yeah.
Let's try. Boop, boop, boop. Go see if you get 3 when you plug that in. Okay, you guys, what do we get for this? What over what? I wrote a 1. What am I trying to fit? Thank you. 12 over 4 is? 3. That was our prediction. Those are the best. We love a little direct substitution, okay? When I did 4 plus 4 plus 4, we got 12. When I plugged that 2 in, 2 squared is 4, plus 2 times 2 is 4. Yep. 12 over 4 gets me 3. He's saying, what the heck? How do I plug a C into the next one? Healed, that is exactly what you do. You say C is some arbitrary thing. I'm just going to plug it in for every X value. You sure are. And what would I have left? C to the 4th minus 2C cubed plus, done. That's all you can do. We have no idea what C is, and healed, you're done. Yeah. That was pretty good. How about over here? You still just do the same thing. This is just me letting you know direct substitution is always your first go-to. C to the 8th minus 5C plus C cubed minus C squared plus 15. Ooh, what did I do? Oh, guys, you just saved me. Just leave it. What if we plug in a 0 here? What happens? Sine of 0 over 0. Sine of 0 over 0. Do you guys agree the sine at 0 is 0? This point is 1, 0, right? The sine, the y is 0. So we'd have 0 over 0. That's when things get a little dicey. We can't divide by 0. That's something called an indeterminate form. I want to show you what this graph looks like, though. Look at what they're asking. They want to know as x approaches 0. That's the limit that we're doing here. As x approaches 0. Guys, does there appear to be a limit?
Yes.
Yeah, it's 1. It's 1. Even though there's a hole here, okay, this is indeterminate form, the limit still exists at 0. So we're going to just say the limit as x approaches 0 of the sine of x over x equals 1. And if I were you, I'd be putting like a flower, anything around that to help remember. This is an identity that we got to remember. When you get 0 out of 0, do not give up right there. It's not that it doesn't exist. This graph shows you that that's not true. But the limit as x approaches 0 is 1. We have to have that one memorized. AP makes us memorize that. What's up, Lai? So now my question is, what happens if we said sine of 4x over 4x? Any ideas? Let's see. Increase the frequency, but as x approaches 0, is my limit still 1?
Yeah.
All right, what about, we did some more in my last class. 10x over 10x. Still 1? Then I even thought, I didn't know this before, what if we negate the x? What if we negate my angle and do negative x over negative x? Check it out, it's the red one. But it's so interesting, and let's talk about why. Because these cannot cancel out. Because you can't mess with an angle and this angle, you can't cancel these out. Why is it the same? Let's think about the unit circle real fast. At this angle, do you agree my y value is 1/2? over here, all the way at pi or at 5 pi over 6, do you agree my y is still a half?
Yes.
So from 0 to pi, my y values all stay the same, and that's what's going on here. Okay, my y's haven't changed. So it is just important to note that, here we go, boom. We got a 1 there as well. You could add another if you wanted. The sign of negative x over negative x is still 1. And then I just kind of wanted to dabble in this because Lila, you and I had kind of talked about, this does deserve a flower. What about as x goes to infinity? We haven't talked about this much. I just want to dabble real fast. As x approaches infinity, I'm going to zoom this out. As x is approaching infinity, do you agree that this is still sinusoidal? But if we're going to infinity, what do you think that y value is approaching?
0.
You agree with that?
Yeah.
So it's just a fun fact. What about if x is approaching negative infinity? My y value is approaching 0 still.
Negative 0.
Just 0, we'd say. So we could say this one is going to be 0. The difference between this first one and this last one, what's the difference between this first flower that I drew? As x approaches 0, so it's asking in the middle versus what's going on over here as we're going all the way to the extreme end behavior. Just a little fun fact. Okay, we're going to do a little pre-calc reminder. Ooh, if we know this identity right above it, sine of x over x as x approaches 0 is 1. Could we use that to help us here? I'm like, dude, I don't know, but maybe I could use my pre-calc to help me. Yes, I could. You ready, Daria? Phone away, please. Thanks. Let's go. Well, what if I put 0 in first? We always do direct substitution first. Tangent at 0. Tangent is which over which? Y over x. What's 0 over 1? 0. So if I plug in a 0 here, wouldn't I have 0 over 0? It's not a determinant. Here we go, y'all. Okay, here we go. Do you agree? It's 0 over 0.
Yeah.
But if I were to look at a graph of this, if I were to go type in, let me get rid of that. Boop, 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 boop. If I were to go type in tangent of x, tan of x, boop, boop, divided by x. Does it look like as x approaches 0 that this has a limit?
Yes.
Does it also look like it has a hole? Yeah. So that's why we got 0 over 0. But, so we got to do something more. How can I rewrite tangent? I love you. Thank you. The fact that you remember that. Tangent is sine over cosine.
How does it do this? Yeah.
Question. What's dividing by x the same as? Dividing by x is the same as multiplying by 1 over x. Dividing by anything is the same as multiplying by its reciprocal. So dividing by x, are you cool if I just say is the same as multiplying by 1 over x? You down with that, Bratty? Okay. Now I got another question. What if I said 2/3 times 5/7? We're going to do that. This is just off to the side. 2/3 times 5/7. What would that get you? 10 over 21. What if I said 2/7 times 5/3? Is that getting me the same thing?
Yes.
Okay. With multiplication, it does not matter the order at all. You're still going to get the same answer. So if I know this, but I need this limit, and I know this is 1, can I manipulate what I have at all? Swap. I love that word. Could I say the limit as x approaches 0? Could I put that sine of x over x?
Yes.
Could I say times what's left? Can I do that? Sure can. We just proved that right here. So, do you agree we know this identity right here? This right here is getting me 1 from right above. So I agree this is 1. But do I still substitute in over here? I sure do. So wouldn't I have times 1 over cosine of 0? You guys, go to that unit circle. What is the cosine of 0? The cosine at 0 is 1. The x value at 0 is 1. So I have 1 times 1, or 1 times 1 over 1, if you want to do that. You know what I'm saying? I don't care. What's 1 times 1?
1.
Woo! Okay, over here, I want you to draw yourself a cute little picture. I just want you to draw yourself a cute little picture. I'm going to put a hole in mine. I don't care if you do. I just have this little graph. Who said I hate graphs?
Braddock.
You guys, if the limit as x approaches c is L, do you agree I've put this symbology in that picture? Does my picture mean the limit as x approaches c is L? Do you agree from both sides? Okay, what if I did this? Does my picture still mean the limit as x approaches c is L? Okay, so you could color your hole in, you can leave it open, I don't care. Here's what I want to show you in nice, like, calculus-y terms. I just want to put this in nice calculus terms for you. Here's how we do it. We're going to say the limit as x approaches c of my function is L. And I should have named my function f of x. Look what I just did there. I said, hey, that's f of x. So the limit as x approaches c of that function is L. Then I'm going to use some fun little notation for you. If. Does anyone remember from pre-calc what that means? If and only if. This is not a mistake. This is like a math term. If and only if. This is how we say it. The limit as x approaches c from the negative side of my function equals L. And what do you think? From the left it equals L. What does it have to happen for my limit to exist? From the right. So we're going to say, and the limit as x approaches c from the right of my function is L. That's a beautiful formal definition of a limit. If from the left and from the right they equal, we're good and we've got a limit. Just very formal. We will need to use that formal notation at some point. Take a peek at this first one. You guys, what happens when we plug in our direct substitution right off the bat? Woof, 0 over 0. The answer is not 0. Let's go take a peek at the actual graph of it. I've got this right. No, I don't. Do I? It's not there, is it? I've got it over here then. I got it over here. We're going to go turn this guy off. Oh, gosh. We're going to turn this guy off. Okay. We're going to go get that guy. Boom. Does it look like as x approaches 0, we have a limit?
Yes.
Do my fingers come together?
Yeah.
About negative, what are you thinking? About negative?
0.4.
Oh, 0.4, because you're seeing that a little bit. Let me do this for us. You're thinking around negative 0.4. 4. Okay. You guys. Anything that you think we could do here algebraically to help us get rid of that hole? What do we all have in common? How many x's do we have in common on the top? So you guys, I'm going to go ahead and just say, let's factor some x's out. As x approaches 0, if I took x to the third out on the top, what's left?
Negative 2x plus 4.
Beautiful. What about on the bottom? What can I take out on the bottom? Another x cubed, leaving me with?
5x.
Beautiful. Question. How many people are like, this is so annoying, I hate bringing this down? I don't blame you, but we technically have to because we're evaluating this limit. If I plugged in my 0 now, would I still get 0 over 0? But right now, wouldn't I technically get 0 over 0 still? Okay, so if you're so right, but I'm just going to say technically here, I'm still at 0 over 0. But my girl Soph goes, hello, we factor those x cubed out, boom, so we could get rid of them. And you're exactly right. So now, as I've got the limit as x approaches 0 of negative 2x plus 4 over 5x minus 9, now when I plug in a 0, what do I get? Negative 4/9, or 4 over negative 9. I'm always going to throw that negative up top. Hey, Graham, do you remember what you guessed was negative 0.45? Do you guys remember what 1/9 is? Ninths are my favorite fractions. 1/9 is 0.11111. 2/9 is 0.22222. 3/9 is 0.33333. What's 4/9? 0.44444. Your guess was 0.45. I'd say that's pretty good, okay? Do you think we got it? We definitely did. So what we've got to do, what we're going to be working on block day as well, is we're going to get this indeterminate form, and we've got to do some factoring, which is why I had you practice it on the summer work to make sure we're good on it. This is the last one. This is it. Here we go. What happens when I plug in a 5? 25 minus 35 plus 10.
That's
0 over?
0.
Okay, we got to do something. We got to do something. They don't all have an x in common this time. What can I do? I made you practice this. Toot. T-O. I need to multiply to be 10 and add to be negative 7.
Minus 2.
Multiply to be 10. Add to be negative 7. You said a negative 5. Whoa. And a negative 2. Why do I like that? That hole is now gone. That hole just went bye-bye. So now that they cancel, I only have the limit as x approaches 5 of x minus 2 left. What's that going to get me now? 3 is what we're saying my limit is. Let's see if I've got that on my calculator over here. Sure don't. Do I have it on this one? Let's see. Yeah, I sure do. Here it is. You guys, as x approaches 5, does it look like my limit is going to be 3? There's a hole there that our calculators don't show us, but that's true. Here's your homework.